Hi, welcome to episode 6 of Coding a Simple Console Game in C. Um, so, in this episode, we will be finishing our game, hopefully. We're getting close to the end. We will be doing our fighting logic and our fighting room. And then we will also fix and implement the error handling, and we'll do uh, the we'll free our memory where it needs to be freed. Uh, so let's just do some notes so I don't forget what we need to do. Okay, so let's see. Let's grab a nice color for our note. What's a nice color? A nice green for our colors. Okay, so let's see. To do the finishing touches, we need the fighting. My God, fighting. We need the for the fighting. We need the player inventory. So he needs to be able to use the item, the potions. The enemies, enemy AI. Okay, whoops. Um, then we'll have, where is it? Okay, we'll have error handling, error handling, and we'll have memory cleanup. Okay, these three things, and we're good to go. Okay, um, this morning, before starting recording, I spent some time not only coding a prototype for fighting, but also reinstalling MSys and um, also uh, checking to see if everything was okay. We get an also we get the segmentation fault sometimes. You got an attack potion, level -3. Let me take these notes down. So the segmentation fault happens when we start at okay, we recover resting room. We got an attack potion. Got attack person. Level -3, which is not normal. Of 100, HP 100, attack 5, and then we get the seg fault. Okay, very sad face. But if you run again, now it's level -1. Now nothing happened. Okay. So we have the seg fault that we have to fix. Fix. Not this, a seg. Okay. So I reinstalled MSys and I did a prototype, but I did the prototype for the combat here in Replit, and it's pretty simple. So we have an enum for turn player and turn enemy, and we have a struct creature that has name, HP, attack, and defense. Then we have this function declaration that has an attacker and a defender. And in here, in the definition, we have a role for a D20. If the role is greater than the defender defense, and the defender HP gets lowered by the attack of the attacker. Then we print the whatever name of the attacker is dealt this damage from whoever the defender's name was. Okay, so the attacker attacks the defenders for X damage. Else it misses. And then we have the fighting loop in here in the main. We seed the randomizer. We create 2 creatures, a player and an enemy. I can put them both in the same place, but it's fine. So creature player HP 100, player attack 10, player defense 12. And I have here an integer create name. While create name, so in this loop, printf enter your name, scanf string player name, your name is this. Is it correct? Yes, no, short choice. If it's different from 1, you get an error, invalid input, please enter your name. Yes, no, continue. If it's no, continue. If it's yes, create name equals 0, and we go out. Then we create, so we're doing some little error handling, and creature enemy 50, a little bit, so half of the player's health. Enemy attack equals 5, enemy defense equals 8, and it's a goblin. Sure, whatever. the AI here gave me the name. I just stick to it. Now we have in combat 1 for the here the little whoops our while loop. We have turn ID turn player. If turn initiative, we have these two roles, player initiative and enemy initiative. We have the turn equals turn player. Player initiative, if it's greater or equal to enemy initiative, then the turn is the player. Player starts, else the enemy starts the combat. Then we get stuck inside the combat. The player HP, if it's equal or less than 0, we're defeated, we get off combat. Same for enemy, if the enemy is defeated, we won, off combat. Now we are in combat, our HP, enemy's HP. If it's the turn of the player, we can attack or we can quit. We have the choice. The choice is equal to 1. We can attack, player as the attacker, enemy as the defender. Else if choice is 2, in combat 0, and break. Bam. Okay, else if turn enemy, then enemy is the attacker and player is the defender. Then ChatGPT told me that this is the way to go, because if we have in our enum more than 2 types of turns or whatever, if you have like turn player, turn enemy, turn anything, or type, imagine if you have like 5 different things, then this will work for each and every single one of them. So it will start from 0 count up to the count, or to less than 1 of the count, and then we'll go back to 0. So it'll work good for our game because we will have max up to 3 enemies, remember, in our fighting room. So this will change between player, enemy, player, enemy, player, enemy. And there you go. This is the simple combat prototype I made. And we can run this. GCC main.c. Run it, enter your name. My name is Super Giga Chad. Name Super Giga Chad, is that correct? Yes. Okay, we are in combat. Okay, we started. We'll attack. Super Giga Chad attacks the goblin for 10 damage. Goblin attacks Super Giga Chad 5 damage. You're in combat. Attack. Super Giga. Goblin misses. Attack. Damn. You have defeated the enemy. Cool. Okay. So here you go. Also, this console simple fighting, which I called it, this is public as well. Everything here in my Replit, this is public. So replit.com @10aigames/console simple fighting. It's public. And I also didn't mention, but in my GitHub, the dungeon crawler, I just updated it 16 minutes ago, and I will keep updating it until we finish the tutorial. And this will be all the code will be here for you guys to it'll be accessible to you, so you can come here, copy it, play around with it. Yeah. Okay. So, okay. let's start with, well, not this. Let's start with doing our um, our fighting, and we have the player. Let's start by doing asking our user for to input the player name, because he should be able to do that. And the player also should have a defense, int defense. Okay, and the enemy should also have an int defense. We'll use the same idea of what we used. And the enemy will also have a potion ID, potion slot. Oops. Because we want the enemies to be able to use potions. Okay. Player defense equals, let's say, 12 for now. And the attack, let's say, 9. Okay. And let's say in player rotates, define player max health max equals 100, and let's say player health max this here, say player dot player max for now. Okay. Now, int choosing equals 1. While choosing name. Okay. So, minor um, here, okay. Input name, let's say char input name 32. So player name buffer max, and we'll say scanf percent Let's say printf, enter your name, player name. Um, um, player name. Excuse me. And if this is different from one, um, uh, right, printf error, um, error naming player. Else, choosing name false, false, so equals 0. Let me copy and over here we do nothing. Let me check. We can do this. I want to say input name, and over here string copy destiny is player name input. Mm, is this okay? Accept. Yeah, buffer overflow. So variable fget string. Query name buffer max is 100. No, it's actually 32. So take you away. Clearing input buffer, leaves trailing new line character. Um, um, Let me tell it, copy this is 32. Ah, my God. What stands for? File get string is a function in C that reads a line of text from a file as an input. Let me sign in. Yeah. Oh my God. Yeah, I'm 27 years old. Wait a second, I'll be right back. Okay. Let's see. And use safe version for your code. Oops. Copy. Okay. Help me check where to implement FDS. Getting the player's name inside main. If fgetS input name. So if fgetS input name, so char now max count player name buffer max and file std. Okay. Now if it's equal to no, so um, yeah, and remove the trailing new line. So size t line. So ooh, size t. Type def and sign long log. Fine. And what do you say? String length. String input name. we say if length greater than 0 and input name length minus 1 equal to new line greater than 0. Whoops. Input name minus 1 equals to new line. So the terminating character. Now this is string n copy. There, name buffer max. And is still the player name. Player max. This one equals terminating character. Ensures null termination. This version uses fgets to prevent buffer overflow, removes the new line character after input, uses string and copy to avoid accidental error. Okay. Getting user input in fighting. SAR user input. Yeah. Okay. So if fgets user input null, yeah, user input error inside. And again, trim the new line. Let me copy this. Okay. Cool. And so here. Okay. print f, let's this enter, press enter. Room treasure. New line. Yeah, some press enter to continue. Okay. Somewhere around here we have an array that's popping. Excuse me. Okay. Okay, we have the, we can now choose the player name. Welcome to this to this game. Cool. Okay, let's do the fighting room. If room fighting, check values and fighting. Player current room. So fighting and check values. Let's take away this function. Let's just do the fighting. The other time we're starting in level 3 for some reason. String n copy 43 61 43 61. Oh, loads. Okay, started on level 2. We didn't start on level 2, we started on level 1. And we went to level 2. And we got a segmentation fault. It showed us the attack. So this is the attack when finding. So the attack went to the weapon slot, weapon names, player.weapon slot. Okay, if player dot weapon slot is equal to no item or not equal, and you can show this. So if it's different from the one, so if it has a weapon, then you can show the weapon. Otherwise, it's trying to go to -1 and it doesn't exist. Tech 9. Weapon slot. Weapon names. Flare and weapon slot. Um, I kind of forgot to compile again. Total. There you go. Now we're stuck in here. Now it's fine. Okay. 1 second. Okay. Now we fixed our segmentation fault. Let's work on our input for fighting, both for our player. So our player can input the fighting, like we saw on the example I did, the prototype. But let's work as well. So on our input for fighting, and if our player has like a potion, he can use it. And let's do the same, but randomly for our enemies AI. And I also have a surprise for you. So let's see. Chana. Bam. Hey. Okay. Shouldn't be in front of the code as well. So Okay, since this is the last episode, we'll extend a little bit, but should be fine. Okay, let's see. Let's change the name for fighting. And let's change the function declaration for fighting loop as well. And let's create another function declaration for fighting. Yeah. And let's say the player will also be a creature, okay? Pointer. Because no, player. And we'll figure out how to decide who's attacking who later on. Okay. Okay, fighting. We'll pass the player. It's a pointer. Player. Here. We'll pass the room. Pointer. Room. Okay. Just like we're doing in the fighting loop. Copy. Paste. Now, let's say int is fighting equals 1 while is fighting. Okay. Now, I'm gonna have to check here. Who's attacking who? So now let me take the space away. Percent d dot space. Right. And now let's see. User input. Okay. I'm gonna have to check which turn is it. It's the same. Here, let's do type define enum. Turn player. Turn turn count, turn over here. This turn ID equals turn where if int of player now for int e0 e less than row current room but enemies length. Okay, equals plus. So for each enemy, I'm gonna check the initiative of the player. Int enemy roll rule enemy roll equals rand percent this one if player initiative is less than or equal is less than sorry enemy roll. Okay, so if the player initiative is less than the enemy roll, and let's say int, we need to know the order. We need to figure out the order. Um, let's see. I want to create an algorithm figures use player enemies and org returns list and returns array of the ordered um, and int array with the player equals 0, any 1 equals 1, etc. Jesus. So players initiative, it's just one player. So there's struct. I don't need a struct. Okay, without struct. Yeah, there you go. There you go. Struct approach was a little bit crazy. Okay, so let's see. Fine. Player d -1. Okay. I don't. It's fine. -1. Okay. So first of all, int enemy excuse me. Okay, so all right, now you do enemy initiatives e equals their initiatives. Now we have make this a little bit bigger. Sorry, realized the text editor was kind of small. So now we have um, um, let's also take this away. Int equals room. Because it's already one more, the length is already one more, no, it's not. Plus one counting the player. There you go. Turns number. Player initiative. Enemy initiatives. And now, let's see. Yeah. Okay. Int initiatives. Paste. This one. Yeah, we'll fix that later. Where are we? Yeah, you're being dumb. Why are you not doing everything here and doing this separate? I don't know. Excuse me. Sorting should do in descent order, swapping both arrays accordingly. I excuse me. I minus count. I Western count -1. So initiative on swap initiative values. No, we have an order. Okay. So okay, let's see. For int I 0 I less than the order count is current length is 1 or -1. What? Why is some -1 here? So initially values equals series and the IDs. So forgot to do the IDs. Count ID for playing for enemies. So room. Mm, D, C, variables these, right, these, these, and fill the order array of sorted items already. So for one, zero, oops, less than this one, y plus plus, uh, order orders have to be dynamic array. Okay. So and this is one, this okay. Checking to see, because I wanna have the player and the enemies and the order like working together. But, still, okay. I mean, this has gone long enough. So what I'm gonna do is I'm gonna stop here, and I'll fix this in the next episode. And I think the next episode will be the last one. And I mean, I'm pretty happy with what we're doing, and I'm learning new stuff as well. So this algorithm is pretty cool. So backtracking and going like back forth, like from back to the beginning, back of the array to the end of from the end of the array to the beginning of the array. Um, it's pretty cool because we start by declaring the I in the columns like -1, and I think because I think this is wrong. I think they actually don't want me to do this. No, it's right. It's -1 because this would be out of bounds if it wasn't. +1. So using I. No. So I have to figure it out to understand it properly. It's pretty cool because it's supposedly sorting it out. Ask it to explain this line by line. So it starts at 0. It represents the current enemy in the list. With condition. Current room enemies length -1. Since enemies length is the number of enemies, this ensures we process all but the last enemy. So it's stupid. Compares the starts one step ahead and generally compare it with the enemies that follow, including one extra slot, possibly representing the player. Loop condition incrementing J moves to the next enemy for comparison swapping initiatives. So in J if needed. Finally assign complete swap. We also swap IDs to keep the correct order. Using temp ID temporarily stores the ID of I before swapping. Assigning IDs to IDs I, so J to I. It's happening overall. So likely a bubble source selection sort likely lol. Compares all enemies, initiatives, and swaps them to range in descending order. Your conditions could be adjusted for clarity. The hell? You wrote the fucking. You wrote the thing, and you're saying your loop conditions could be adjusted for clarity. Dividing +1 an enemy's length makes it move more into. Okay, yeah, sure. Let me know if you. Yeah, sure. Okay. Anyway, let's stop here and um, we'll finish the implementation of the finding in the next episode, and probably we'll make the next episode the last episode. Okay, so I'll see you guys there. Bye.